Good morning. This lesson's on separation techniques for mixtures. So remember mixtures? We've got our homogeneous and heterogeneous mixtures. This means we have more than one different types of particles that are physically in the same space but not chemically bonded together. In a homogeneous mixture, you can't see the difference between the different particles that are in that substance. Are all so well mixed together. They're evenly spread throughout. Can't tell the difference. Heterogeneous mixtures, you can immediately tell the difference, or if you let it, like if it's a liquid, settle and wait for a moment, you'll eventually be able to see the difference as the different particles separate out. To do this, you'll also need knowledge of physical properties. So those properties that are inherent with a substance. The first way in which we humans can separate mixtures. Most of the world around us are mixtures. And there are many reasons why for the goods and services, well, not services, all the goods we have in our house, all the different products we use, we don't find these in nature. We need to be able to extract the active ingredients from something and recombine them into a different something. That requires separation techniques. That requires knowledge of chemistry, knowledge of a difference in the property of some parts of that substance from the other parts of the substance. If you have that knowledge, then you can use some pretty simple techniques to then just be able to pull apart the different parts of the mixture. First one I want you to look into is filtration. You should be very familiar with that, with filtered water. If you're in your kitchen, turn around. You probably have filtered water coming right off of your sink or coming off your tap. Or you buy filtered water from the store. Tap water's fine too, but not filtered. Go ahead and click that link right here and then write down the steps that are involved in filtration. Write down any new vocabulary, like what is a filtrate? And then which physical property is allowing for separation? Which physical property is being taken advantage of? A difference in boiling points or a difference in particle sizes? One last example of filtration. If you're making pasta today for lunch or dinner, you're probably using a very crude version of filtration. A colander and pasta and water. You have a mixture of pasta and water. You use the colander, which has little pores in it that allow water through, but not the pasta. Go ahead and watch that video and then come back. Pause this one and come back. All right, after you've watched the filtration video, next watch distillation. Examples of distillation you've probably heard of: distilled water, another water product you can just buy at the store. Other forms of distillation, you're going to see an example later in this same lesson for how we get the different gasoline, gasoline versus jet fuel versus kerosene from crude oil. Crude oil is distilled to give us all the different petroleum products in the plastics that we use and in the fuel we burn. Also see it in spirit making, so vodka, any of the hard alcohols, that is also a distillation process. Or, very topical for COVID-19 right now, hand sanitizer. Hand sanitizer's active ingredients of isopropyl alcohol or ethanol are also products of distillation after fermentation has occurred. Go ahead and click that video tutorial, again taking notes of steps and new vocabulary, and then circle which of these boiling point or particle size is being taken advantage of. Next, go ahead and watch the video for evaporation. It is not as step-oriented and scientific as the previous two. It is actually an advertising video that I have linked here, but it's really cool. So go ahead and do the same thing here. And I have already told you what is allowing this separation and ability to evaporate. It can be done in a lab by taking advantage of boiling points as well. Last one I want you to click is crystallization. click that video, write down the steps, write down the vocabulary, and I have already defined it as an ability to crystallize. Remember that ionic compounds like to crystallize, as do metals. Last, go ahead and practice. Deduce the steps required to separate the following mixtures. In the following situations, deduce questions require that you justify your choices by incorporating specific data, meaning numbers, from the question into your answer. Don't just say, I did this, done. First one is about obtaining pure, clean drinking water. Here are the physical properties of the different components of river water. Go ahead and classify that river water as one of our 4 types of matter. And then tell me what method we'll use to separate it, what physical property is being taken advantage of, and what are all the steps and justifications for those steps that will allow you to get pure, nothing but water, and to be clean. All right. Next one is the crude oil example. Here are all the different parts of crude oil. Here you can see crude oil, and here's everything that's in crude oil. And here are some boiling ranges that would allow you to get the different parts of our crude oil mixture out. This is one distillate that can come out. You can see this component of crude oil mixture is very different. Go ahead and classify that crude oil you see here. And then same as before, what method are you going to utilize? What physical property will allow you to separate all of these different products from this crude oil liquid? And go ahead and explain and justify how you would do that. Last one, got a mixture of salt, sand, and iron. Classify it based on this image, and then outline how you would separate all 3 parts. Here you can see the 3 different subcomponents if you were to filter this, or not filter necessarily, to have separated it. One note, pure water, this can be a single step, and I want you to think of it as a single step. To get, what did I want here? I think I asked for jet fuel. Yeah, jet fuel. In order to get jet fuel, I want a 2-step process. And in order to fully separate your iron, your salt, and your sand into 1, 2, 3 different containers, you will need more than 2 steps. All right, good luck, and this is it for our unit on matter.